All right, so here it is, the last video. Hopefully you've enjoyed, to an extent, having the flipped classroom for this unit. All right, so let's take a look. We've got a little bit of more gas stoichiometry to take a look at. We are now going to throw into the mix the idea of molar mass and density. So same idea that you did with the first gas stoichiometry. I've got 5 proofs that I want you to complete. And in this case, the first 4 hints that I've given you are the same as the first set. Gas laws only apply to gases. Number 2, you've got that liter ratio or that volume ratio that we saw. Number 3, standard molar volume still works at STP conditions. 1 mole of gas occupies 22.4 liters. Number 4, PV equals nRT. We're actually going to use that in a little bit of a unique way in this organizer. And then the last 2 ideas, density, remember, is equal to mass divided by volume. And it looks a lot like moles divided by volume, so keep that in mind. That's where we're going to go with that idea. And then also, don't forget, molar mass is equal to grams per mole. So no overall equation to do with this. You've got 5 not quite related problems, unlike the last set. It's also going to be a little harder to organize your thoughts on this. But go ahead one more time and stop the videotape. Try and come up with some of those ideas yourself. And then we will turn the video back on and we'll take a look at the ideas that you came up with and see how you did. All right, so I assume that you have stopped the videotape and have tried the practice stuff, or tried to do the proof. So let's go through what you found. All right, the first question, at STP, 1 liter of gas weighs 2.68 grams. Prove that its molar mass is 60 grams per mole. So keep in mind that you have grams per liter and you have grams per mole. So somehow you got to get from liters in the denominator to moles in the denominator. Since you're at STP, is there any little conversion factor going off in your head that you know? Hopefully you know that if you use standard molar volume, you can get liters to cancel out by writing it appropriately in a conversion factor, and you are left with grams on top and moles in the denominator. So you will get the density. I'm sorry, you'll get from the density to the molar mass. All right, next idea. Like I said, these aren't really very related. You have constant conditions of 25 degrees Celsius and 0.8 ATMs. Prove that 5 liters of gas at this condition is going to weigh 6.22 grams, so prove that the molar mass is 38 grams per mole. So since you are at conditions that are not STP, you can't use 22.4 liters per mole. What you can use is PV equals nRT. So this is going to be another one of those 2-steppers. You're first going to have to prove that the 5 liters of gas is going to be equivalent to 0.164 moles. And then once you get moles of gas, you also have grams of gas. So grams divided by moles, grams per mole, is molar mass. So once you have your moles, it's simply a matter of taking those 2 numbers and solving for molar mass. So the second half is not dimensional analysis. You're going to see a few times on here where we're actually not using dimensional analysis to solve things, because we just have to take the units and put them together in a conversion factor. So what we're doing in some cases is actually creating our own conversion factor. All right, so there's number 2. Let's shift down to number 3. This one is probably the most challenging, but hopefully the most logical that you wind up seeing. So you have a cylinder of gas X, which weighs 21.8 grams. Under the same conditions, so same cylinder, if you put nitrogen gas in that cylinder, it weighs 15 grams. So what I want you to do is prove that the molar mass of X is 40.7 grams per mole. So to do that, you got to keep one thing in mind. You got to remember that since it's the same cylinder, under the same conditions, you have the same amount of moles in that cylinder. So if you can figure out how many moles of nitrogen gas you have, you know you have an equal number of moles of gas X, and that's what's going to get you to your molar mass. So first and foremost, 15 grams of nitrogen gas will wind up being equivalent to 0.536 moles of nitrogen gas. Since it's the same cylinder, you also now know that you have 0.536 moles of gas X. So that's the relationship you've got to remember. Same conditions, same volume, same moles. So one last step to get the molar mass of gas X, what do? You divide the 21.8 grams by the 0.536 moles, and you wind up with 40.7 grams per mole. All right, there's idea number 3. Moving on, we're going to switch to idea number 4, and I completely forgot to write the question. Sorry about that. So we are looking at a sample of oxygen gas is at a temperature of 30 degrees Celsius and a pressure of 98.5 kPa. Prove that the density of the gas is 1.25 grams. So what we're going to do here is something that I alluded to when I introduced the ideas to you. N over V is equal to P over RT, because N over V looks kind of like a density. You've got the quantity of material divided by a volume. So this is a little trick that will help shorten some of the problems that you're faced with for homework this evening. So you've got the kPa is 98.5 the pressure is 98.5 kPas. So you got to convert that to ATMs because of our 0.082. Temperature is 303 Kelvin. So you wind up with a pseudo density of 0.039 moles per liter. Last step, since you know it's oxygen, you are going to convert with molar mass from moles per liter to grams per liter. And so you wind up with a density of 1.25 grams per liter based upon that information. So you can see this problem set is not quite as clear-cut and as the first set was, but it's using little things that you already know to solve problems. All right, the last one, number 5. A reaction calls for CO2 gas that has a density of 1.45 grams per liter at 20 degrees Celsius. Prove that the pressure of the CO2 is going to have to be 601.7 millimeters of mercury in order to accomplish those criteria. So we are going to figure out what the pressure is going to have to be, or we're going to try and prove that the pressure is what the question says it is, the 601.7 millimeters of mercury. I'm going to set up, essentially here's PV equals nRT, solve for P, but I'm given grams. So this little step right here lets me convert from grams into moles. So there's my N. So there's my N. Here's my R. Here's my T. There's my V. So once I get a pressure, remember that that pressure is in ATMs. So I've got to do one small conversion in order to get it to millimeters of mercury. So hopefully at this point you are seeing that stuff that you already know is just going to be used in a slightly different way to solve problems. That's what all of this analytical thinking is trying to, or all these problem sets are trying to get you to do, think analytically about stuff. So there's not a big way for me to summarize things. Whatever you need to do with the ideas that helps you make sense. Think about the fact that we have this one expression that looks similar to density. This is something that might be useful for you to remember. And also the whole idea of molar mass. Molar mass is grams per mole. So, all right, last set. Good luck. Thanks for listening. Bye.